There are 3 simple gas laws that you guys need to know, and then 1 additional gas law that takes all 3 of them and combines them. And the first of these gas laws is Boyle's law. And Boyle's law is the law that states that pressure and volume differ inversely. So as one goes up, the other's going to go down. And the formula for calculating Boyle's law looks like this. And all you have to do is take the pressure of the starting pressure times the starting volume is going to be equal to the second pressure times the second volume. And then we have Charles's law. And Charles's law relates volume and temperature, saying that they change in the same direction. So if temperature goes up, volume's going to go up. If temperature goes down, volume's going to go down. And that looks like this. You have V1 over T1 equals V2 over T2. And if you remember from class, I like to write this. I'm not really fond of fractions. So I'll usually write it as V1T2 equals V2T1, which is just taking this original equation and cross multiplying it. And then for your last law, you have Gay-Lussac's law. And Gay-Lussac's law relates the last combination, the pressure and temperature combination, and it looks really similar to Charles's law in that pressure, the starting pressure over the starting temperature is equal to the ending pressure over the over the ending temperature, or the two of them are directly related. And again, instead of doing a fraction like this, I like to do cross multiply and turn it into just a regular old multiplication. It's just easier for my brain to interpret this than it is a fraction. And give it a second while that loads up. There it goes. So then there is a third and final law that takes all 3 of these guys' laws and puts them together in one nice, neat little package. And that law, it's called very creatively the combined gas law. And it's equal to, P1, V1 over T1 equals P2 V2 over T2. And all it is literally is taking each of these 3 laws and combining them, and that's all that it's doing. And just like with Charles' law and Gay-Lussac's law, I'm not a fan of the fraction, so I typically will write this as P1 V1 T2 equals P2 V2 T1. And something that you need to remember on all of these laws is that temperature, these temperatures, all of the temperatures absolutely have to be in Kelvin. Oops, sorry. If it is not in Kelvin, you will not calculate the correct answer. With pressure and volume, all you have to do is make sure that the 2 of those guys are in the same unit. So, you know, if this pressure over here is in atmospheres, then this one needs to be in atmospheres. Or if this volume is in milliliters, then this volume needs to be in milliliters.